Okay, so I had a question on this one. So we're trying to find cosine, and we have to kind of remember what cosine means. Cosine means adjacent over hypotenuse, right? They give us tangent of beta, which is 5. So it's actually kind of saying like 501, right? And then we know that sine beta, tangent beta is our opposite over our adjacent. Okay? Then it says sine beta is less than 0. So that's gonna take some thinking, right? As far as what does that mean? That just kind of means what quadrant we're in. But first, before we get to this part, I want us to kind of dissect what we know. So we know opposite and adjacent. So whenever we have a triangle, right? Let's say, well, you know what? Let's start off with the quadrants first. So sine beta is less than 0. So we kind of want to use our notes and figure out when is sine beta a negative, right? And there's actually um, two quadrants that happens, okay? And it's important that we kind of see that because um, our sine beta involves our our opposite and our hypotenuse, right? So, recalc, and I believe it was one that we did that. Okay, I can't remember where it was at. Remember, we had a little chart. Oh, right here. Okay, sine beta. When is it less than 0? When less than 0 means it's negative, right? So it's going to be in quadrant 3 or in quadrant 4. Okay, so our sine beta is going to be either in quadrant 3 or in quadrant 4. Okay, now we already know tan beta is a positive, right? It's a 5 over 1. So that means not being quadrant 4 because that would make us have a negative uh, tangent beta. So right here, we're going to have a positive, a negative, so we're going to be in quadrant 3. Okay, so this state, since this is positive and this states that sine beta is um, less than 0, which means a negative number, we're going to be in quadrant 3. And that's going to be kind of important. And that's important when we're dealing with our graph, right? So when we're drawing our graphs, we're going to, oh my, forgot, hold on, erases. Let's change this color to red. So we have our, oh my goodness. Let me see if I can draw that a little bit better. I mean, the drawing doesn't really matter, but it helps. So we have our x-axis, and then we're going to have our y-axis, and I'm going to draw the quadrant 3 because we just figured out that it was quadrant 3. Okay, so now I'm going to draw my triangle, right? So I have my triangles like this. Okay, this is the right triangle. This is beta. So that means I'm going to have a negative x, a negative y, and I should really add it. Can I add another tool here? Add, no, can I? Let's see if I can modify this to something else. No, I can't. No, no. I want another pin. Okay, well, anyways, so we can't do that. Okay, so I'm just gonna write this in R. Okay. Oh my goodness, that's horrible. That's good. I'm gonna stop color coding. Okay. So now we know that this is opposite to the adjacent, okay? So even though it's positive, right? Uh, there's a key thing that's happening here. So we know that opposite the beta is 5, okay? But we know it's going to be negative because it's going down. And our adjacent is also 1. And we also know that this is going to be negative. And that's the key part because the reason that it turns into a positive because a negative over a negative is a positive, right? So if you say negative times negative is positive, negative divided by negative is also positive. So technically, um, I really wanted to look at it like this. So negative 5 over negative 1, which turns into this, right? The negatives cancel. That helps. That's good because that helps me figure out that yes, we are in quadrant 3. Okay, so now all we need to figure out is r. So how do we figure out r? Pythagorean theorem. So we can go negative 1 squared plus negative 5 squared, and that's going to equal to r squared. So this is 1 plus 25 equals to r squared. 26 equals to r squared, and we take the square root of 26, which is r. And remember, we always have a plus and we always have a minus, right? So now, and here's where it gets tricky right here, right? So we need to figure out, are we going to use the positive square root of 26 or the negative square root of 26? So let's look at the graph, right? Let's look at my triangle. Is my r a positive slope or a negative slope? So those describe this. Would I be describing this as a positive, like going up or going down, right? So in this case, the r is going up, positive. So I want to be able to be sure that I'm using the correct r, okay? Because in this case, I still have two options, okay? So now, my cosine. My cosine would just be my adjacent, which I already know my adjacent. It's going to be my negative x. So my negative x, which would be, in this case, negative 1. And then my hypotenuse, which in this case would be square root of 26. However, we spoke about this today that we cannot have a square root on the bottom. So what do? We multiply it by square root of 26 over square root of 26. We rationalize. So, I forgot theta. Okay. So my cosine theta would equal to negative square root of 26 on the top. These two just become a positive 26. So that would be our way to our process that we would need to answering this question. Okay. So in this case, my answer would be C. Hope that helps. Now, I know you said you also had a question on number 6. Question number 6 is I'm gonna kind of split screen. Question number 6. We first gotta identify what kind of function this is. Like, so this graph that's given to us. Whoops! I didn't want you to see them. So what kind of function it is, right? So I kind of gave it away, right? It's pretty. So the function is a tan, right? So we have this graph right here, this tan. So what it's asking you is to compare two different ones. Compare the positive tan with that of a negative x. So um, does this graph, sorry, yeah, so this graph, that's which this one is. This one's just shifted a little bit. Um, does that equal to does the positive one equal to the negative x one? So if they overlap, then we are okay. If they don't overlap, then we are not okay. So let's see. So I'm going to click this one. So by the way, I just kind of typed them in. I typed tan of x because that was the parent function. And then I've just typed in a negative on the inside with the x. And then on this one, I did a negative on the outside. So just those three options, okay? So I look, And I noticed they do not overlap. They actually intersect, right? So they're different. Technically, A would be wrong. Okay. And given that this is only two answer choices, we already know the answer choice is B. However, I want to go into it. Okay. Now it's saying, does the negative x, so negative on the inside, would that equal to if the negative was on the outside? Okay, notice negative on the outside, negative on the outside. So let's see if they overlap, then they're the same, they're equal to each other. So I'm gonna click, bada boom, they overlap. So you can't really tell, but they are overlapping. So you see the green, and then you can kind of see the blue on top of the green. So they overlapped. So that means they are equal to each other, and that's our answer. I hope this helps. Um, let me know. Let me know how it goes. Laters.